Alright, welcome to today's lesson on collection classes, where I'm going to go over a brief overview of three different collection classes that we have available to us to work with sets of data of the same type. Now, in previous lessons we learned about arrays, which is a common and simple way of manipulating sets of data of the same type. But there are actually other options available to us depending on what the data is and how we want to work with it. So today we're going to take a look at lists, sets, and maps. What you need to know about each of these collection class types is that there are a variety of subclasses available for each of these types as well. For our purposes in this course, we're really only going to look at the ArrayList, the HashSet, and the TreeMap. But just realize that there are other versions out there that can provide alternate modifications of how they work as well. So a list is basically an ordered collection of elements which may contain duplicate values. This is very similar to an array, also an ordered collection of elements with indices, and can contain duplicate values. The difference is that a list is dynamic while an array is not dynamic, it is static. So a list can grow in size. I can add new elements to it and make the list get bigger as I go, or smaller. Whereas an array has a certain set size when I first create it, and that is the size that is going to be at all times. A set is different from both of those because a set is an unordered collection of unique elements. So a set does not have an index, it just has basically a set of data. And those elements in that set of data are going to be unique. So I cannot have duplicate values stored in a set. A map is different again. It is an ordered collection of keys, and each key is linked to an associated value. So think of this as like a set of student numbers. Each student number is ordered from smallest to largest. It cannot be duplicated, and each student number is linked to an associated student that goes along with it. So I can search through all the student numbers to find a specific student. Let's look at these in a little bit more detail. So we'll start with the ArrayList. All three of these classes are actually part of a java.util package. An ArrayList specifically will keep your elements in order, just like an array would. Any element can be accessed by looking at its index. So the indexes go from 0 to whatever, and that keeps track of all of your elements in that order. Again, the difference between this and an actual array is that it is dynamic. The size of the ArrayList can be modified in real time as we go through our program. Some of the drawbacks of working with an ArrayList is that, number one, it can only contain objects, so you cannot use primitive data types here. And it can only be one-dimensional. You cannot have a two-dimensional ArrayList or a three-dimensional ArrayList. Now when you want to work with an ArrayList, you use a basic constructor here. The keyword here, ArrayList, tells us what type of collection class we're working with. And then in these angled brackets, we put the type of object we're going to create, give it a variable name, and then we say that it's going to be a new ArrayList of that object type. So it looks like this. If I was going to make an ArrayList of songs, I'd have ArrayList song called ICS tunes is going to be a new ArrayList of song objects. Now that I have my list, I need to add elements to it, and that is done simply by using the add method. So I just go that ArrayList.add and then provide it the element that or the object that I want to add to the list. And this will add that element to the end of the list and make that list grow by one more as we go. If you don't want to add your element to the end of the list, you can do it by using an additional parameter by saying what position you want to insert the element into. So for example here, I've got ICSTunes.add my song, which would add a song to the end of my song list, or I can add it to position 2. And then whatever was in position 2 will move to position 3, whatever's in position 3 will move to position 4, and so on until I get to the end of my array list. I can also get and set elements within my array list. So get, I provide the index of the element that I want to get, and it returns that particular element. Set will basically allow me to replace an element at a particular index. So here again, if I get the song that is at position 2, or I replace whatever song was at position 3 with this new my song. You can also remove elements from an array list. You do this by using the remove method, and you provide the index of the element you want to remove, and it will return that as an object. Okay. Once you've done that, all elements that were after this element are going to be shift upwards. So for example down here, I'm going to remove whatever song was at position 2. It gets returned back to this deleted song object, and then whatever was at position 3 is going to go now into position 2, whatever was at position 4 is now at position 3, and so on, shuffling all the songs up by one until I get to the end of the array list, which gets deleted completely, and now the size of my array list is one element less. So the second type we were going to look at was the set class, specifically the HashSet. Again, this is also part of the java.util package. Remember that with the hash set, elements are not in any particular order, so there is no index to keep track of the elements in our hash set. It is dynamic, which means that as I add elements into my hash set, the size of the hash set will increase as I go. Much like the array list, it can only contain objects, and all elements must be unique. This means that if I try to add an element that already exists, it will be ignored. Right? This is useful for, again, doing things like student numbers. I can't have two students with the same student number. So if I try and add another student number into that set, it's going to throw me back. It's not going to do it. It's just going to be ignored. Okay? And hash sets also can only be one-dimensional. The constructor for a hash set looks exactly the same as it did for an array list, except we're changing out the keyword here for hash set. And then there are a variety of useful methods that we can use for our hash set. We have an add method, which works a little bit different than we saw in the array list. I provide the element to add, but what it's going to actually do is return a Boolean value to tell me if that element was already in the list or not. Because again, it won't add it if it's already there. So if the element is already in our hash set, it's going to return true. If it is not in the hash set, it will return false. I can use clear, which is going to remove all elements from my set. I can check to see if my hash set contains a particular element. If that element is in there, it will return true. If it is not, it will return false. I can remove a particular element from a hash set. This is slightly different again from the ArrayList remove method in that it doesn't actually return the element you're removing. Instead, it returns a true or false, telling you whether or not that element was there or not. If it was there, it removes it. If it was not there, it returns false and does not remove anything. And then I've got the size method, which tells me how many elements are in my hash set. The third and final type of collection class we're looking at today is the map class, specifically here the TreeMap, again found in the java.util package. Remember that the TreeMap works as keys and values. So I have a key, which is a set of unique values or unique data pieces, each of which is going to be linked to a particular value. So in this case, maybe I'm going to have a set of keys, which are my student numbers, and each student number is going to be linked to a particular student value. Okay? When you're doing this, all of your elements are going to be arranged in order by the key. So if I had my keys being integer values, they would be organized from lowest to highest. If my key was going to be strings, they'd be arranged in alphabetical order. If it's going to be some other type of object, then you have to have that object must have a compare to method so that it can be ordered properly. Tree maps are dynamic, so the size of the tree map can be modified in real time. As I add more elements and keys, it will expand in size. Both keys and values must also be objects, although they can be different types of objects. So I don't have to have string, string, int, int. I can have int, string, int, student, whatever I'm going to be. If I want this to be an integer, though, remember it must be an object. So I have to provide a wrapper class for the integer values here so they can be worked with as objects. All keys must be unique. We said that before. And associated values can be duplicated. So although keys must be unique, I can only have one specific student number, I can duplicate values. So I can have multiple keys linking to the same values. So for example, I can have two student numbers that both live at the same house. So I have multiple values there, right? Multiple keys pointing to the same value. I've got the same house or address listed twice. Okay? So the constructor here, we've got our tree map. We have to provide the key type first, then the value type, then our names. So for example, if I was going to do a phone book, I'd have the string being the phone number as my key, because I can only have one individual phone number, and then I have the values here, because I could have multiple people, each with a different phone number. So string for the phone number, string for the person. There are a variety of useful methods that we can have available to us for the tree map. We've got put, okay, where it's going to associate a particular key with a particular value and put that into my tree map. Okay. I can get a particular object. Okay. With this put one, if I try and put something into a particular key, if this key was already linked to a value, it will return the value that used to be linked to it as well, and then it'll link the new value with it. I can get a value, so I provide the student number or the key, and it will provide the student or the object that is associated with it. I can remove a value from a key. Okay, so I have my key and it removes the value that was associated with it. I can clear out all my pairs. I can just get the set of all the keys. So if I just want to know what all my keys are, it returns that as a set. So I could scroll through all those keys if I wish to look at each individual value. And then I can also check to see if my map has a specific value within it, okay, which gives me a true or false answer. So it can be difficult now that we're working with some things that don't have an ordered set of data. We don't have indices. Maps and sets don't use indices. We need to have a way to loop through all the elements. And we can do this by using a new type of loop called a for each loop. This will cycle through all the elements in a collection by assigning each of them a temporary variable. And it looks something like this. For all the element types, I'm going to create a variable name in a particular collection. And then I do statements to that thing. So you look here and you say, this is the type of element in my collection. This is the name of a temporary variable where I'm going to store each element in that collection. And this is the collection I'm searching through. So I would search through a particular collection, get each variable name, do something to it, get the next one in that collection, do something to it, and so on. Okay, so you can see, for example, here, I'm going to search through my ICS tunes collection, pulling out individual songs one at a time, each of them being called current song. And then I can do something to that current song. So this code here would go through every single song on my list and change its rating to a rating of 4. In a tree map, it's slightly a little bit more confusing because we have both keys and values. But remember, each value is linked to an associated key. So if I use the key set method, what that will allow me to do is return all the keys in my address book, my tree map of address book, go through each key and store each one of those keys as a key, and I can do something with it. So again, in this case, I was going through my address book. It would get each key, each person, it would return that key. I can then go, here's what the key is, here's what the person's name is, plus, and now get that particular key's value. So in this case, their address. Okay, so this will output the entire collection of addresses in my address book. The key, and then the value associated with it. And remember, as I was saying earlier, all of these collections are unable to use primitive data types like integer, char, and double. So you have to use a wrapper class that we've talked about in one of our previous lessons to convert those primitive values into an object, like the integer, boolean, double, or character, so that we can then use those in our collection classes. That's it. That's all we have for today. We'll see you in class tomorrow where we can practice what we've learned.